Hi, welcome to the Corbettmaths video solutions to the Algebraic Proof practice questions. If you want any extra help on Algebraic Proof, if you go to corbettmaths.com/contents and you scroll down to video 365, there's a video tutorial there on Algebraic Proof. In this video, we're going to focus on the video solutions to the practice questions, so let's get started. So question number 1 says, prove the sum of 3 consecutive integers is divisible by 3. So let's think of 3 consecutive integers. Now it doesn't specify whether they're odd or even, so it's just going to be 3 consecutive integers. So for instance, we could let the first number be called n, the second number would be n plus 1, and the next number would be n plus 2. So they are 3 consecutive integers. Now it says the sum of 3 consecutive integers is divisible by 3. So if we add them together, we'll find the sum of 3 consecutive integers. So let's add our n plus 1, and our n plus 2. So let's add n plus 1, and n plus 2 together and see what we get. Well, n plus n plus n is 3n, and 1 plus 2 is equal to 3. So if we add 3 consecutive integers, n plus 1, and n plus 2 together, we get 3n plus 3. Now to show it's divisible by 3, we want to factorize this and take 3 out as a factor. And we can do that because if we were to factorize this, we would get 3 bracket n plus 1. Just dividing both of these by 3 would give us our n plus 1. So we've got 3 bracket n plus 1. And as you can see here, that's 3 times something. Now because it's 3 times something, that means it's divisible by 3. It means it's in the 3 times tables. So that's it. So therefore, and I've just written which is divisible by 3 because we've got 3 times something, and that's it. So we've proved the sum of 3 consecutive integers is divisible by 3 because n plus 1 plus n plus 2 is 3n plus 3, and we can take 3 out as a factor, so we've got 3 bracket n plus 1, and because it's 3 times something, it's divisible by 3. So that's it. Okay, let's have a look at our next question. So our next question says, prove n plus 6 close bracket squared subtract n plus 2 close bracket squared is always a multiple of 8. So what we want to do here is we want to expand our brackets because it says squared, that means multiply the bracket by itself, and we're going to take them away and see what we get. So we've got n plus 6 close bracket squared. Well, if we were to expand that, that would be equal to n plus 6 brackets n plus 6. And when we expand that, we would get n times n is n squared, n times 6 is plus 6n, 6 times n is plus 6n, and finally 6 times 6 is 36. So that would be n squared plus 12n plus 36. So that's what we get whenever we expand this bracket. Now we're going to expand this bracket, which is our n plus 2 close bracket squared. So n plus 2 close bracket squared. When we expand that, that would be n plus 2 times n plus 2. And when we expand that, we get n times n is n squared. And then we've got n times 2, that's plus 2n. 2 times n, that's plus 2n. And 2 times 2 is plus 4. So that would be n squared plus 4n plus 4. So we've expanded our first brackets, we've multiplied it by itself, and we've expanded our second brackets by multiplying it by itself. And now we need to take them away. So we need to do n squared plus 12n plus 36 subtract n squared plus 4n plus 4. So let's write that down. So that's going to be n squared plus 12n plus 36. Now we're subtracting all of this, so we're going to be subtracting, and then in brackets, n squared plus 4n plus 4. And let's see what we get. Well, n squared take away n squared, that's just going to be 0. Then we've got 12n take away 4n, or 12n take away positive 4n, 8n. And then we've got 36 take away 4, and 36 take away 4 is equal to 32. And that's it. So whenever we expand our brackets and take them away, we get that's equal to 8n plus 32. So we want to show this is a multiple of 8. Well, if we want to show this is a multiple of 8, we want to take 8 out as a factor. So it's going to be 8 bracket. And then if we divide both of these by 8, we'll get n plus 4. And that's it. So 8 does come out as a factor. We've got 8 bracket n plus 4. So that means that that is a multiple of 8. So let's write that down. Therefore it's a multiple of 8. Okay, let's have a look at our next question. Question number 3. So question number 3 says, prove n plus 10 close bracket squared take away n plus 5 close bracket squared is always a multiple of 5. So let's expand our brackets. So we've got n plus 10 multiplied by n plus 10. So let's expand those and see what we get. So n times n is n squared, n times 10 is plus 10n, 10 times n is plus 10n, and 10 times 10 is 100. So that's equal to n squared plus 20n plus 100. So that's what we get when we square our first bracket. Now let's square our second bracket. So n plus 5 multiplied by n plus 5. And when we do that, we get n times n is n squared, n times 5 is plus 5n, 5 times n is plus 5n, and 5 times 5 is 25. And when we add those together, we get n squared plus 10n plus 25. Now we want to take these away and show it's a multiple of 5. So let's take them away. So let's write down our n squared plus 20n plus 100. And we're going to take away, and that's important to put this in brackets because we're taking away the whole thing. So in brackets, n squared plus 10n plus 25. So let's do that and see what we get. N squared, take away n squared, that's 0. 20n, take away 10n. Well, 20n take away 10n will be 10n. And finally, 100 take away 25 is equal to 75, so plus 75. So when we expand our brackets and simplify, we get 10n plus 75. Now we want to show that's a multiple of 5. Well, we can take 5 out as a factor, so that's going to be 5 brackets. And then if we divide both of these by 5, we get 2n plus 15. And that means we've got 5 times something, so that means it's a multiple of 5. So let's write that down, therefore. And that's it, so I've just written therefore a multiple of 5. Okay, let's have a look at our next question, question number 4. So let's have a look at question number 4. So question number 4 says, prove the sum of 2 consecutive odd numbers is even. So we want to show that if we add 2 consecutive odd numbers that we get an even answer. Now in this question we can't use n because n can be any number. It could be 5, it could be 6, it could be 7, it could be odd or even. So we want to find odd numbers. So remember, if we have n, if we multiply by 2, that would be 2n, that's even. And then if we add 1, 2n is even, plus 1 would be odd. So our first odd number we're going to use is 2n plus 1. Some people like to use 2n minus 1. I like to use 2n plus 1. Okay, I'm kind of a positive guy. I like to add 1. So we've got 2n plus 1. Now what we're going to do is we're going to find the next odd number. Well, 2n plus 2 would be the next number. That's going to be even. And then it would be 2n plus 3. That would be the next odd number. So these would be 2 consecutive odd numbers. Because 2n is even. If we add 1, that would be odd. We can't have 2n plus 2, that's even, so we've got 2n plus 3. So there are 2 consecutive odd numbers, and we want to show that their sum, when we add them together, we get an even answer. So if we add these together, hopefully we'll get an even answer. So let's see what we get. So we've got 2n plus 2n, that's 4n, and then we've got 1 plus 3, that's 4, so we've got plus 4. So the answer is 4n plus 4. Now we want to show that's even. Well, that is even, because if you think about it, 4 times a number would be even, plus 4 is still even. Now to show it's even, I like to take 2 out as a factor. I like to factorize and take 2 out, so it's 2 times something. So let's factorize it, so let's take 2 out. And then divide both of these by 2, we would get 2n plus 2. So it's 2 times something, so therefore it's even. So let's write that down. So I've written therefore the sum is even because we've got 2 times something. Now one thing to notice here is we could have taken 4 out as a factor instead of 2. I like to show if something's even to show it's 2 times something. But here we've got 4n plus 4. We could have taken 4 out as a factor and got 4 bracket n plus 1. And because it's 4 times something, therefore that's even as well. And that's it. So in this question we're asked to prove the sum of 2 consecutive odd numbers is even, and that's it. So we've done that. Okay, let's have a look at our next question, question number 5. Okay, let's have a look at question number 5. So question number 5, we've been asked to prove that this is always even. So we want to expand this and simplify it and see what we get. So let's expand our first pair of brackets. So 2n times 3n would be 6n squared. We've then got 2n times minus 2, that's minus 4n. We've then got 1 times 3n, that's plus 3n, and then we've got 1 times minus 2. Well, 1 times minus 2 would be minus 2. So let's simplify this now. So we've got our 6n squared. We've then got our minus 4n plus 3n. Well, if we had minus 4n and we add 3n, we get minus 1n, or just minus n, and then we've got our minus 2. So whenever we expand our first pair of brackets, we get 6n squared minus n minus 2. Now we're going to take away whatever we get whenever we expand this, so let's expand our next pair of brackets. So 6n times n is 6n squared. 6n times minus 2 would be negative 12n. Negative 1 times n would be negative 1n, or just minus n. And then negative 1 times negative 2, well, negative times negative is a positive, so that'd be plus 2. So we've got 6n squared, and then we've got minus 12n minus another n, that'd be minus 13n plus 2. Now we've been asked to prove that whenever we take these away that it's even. So we're going to take away these results. So we're going to do 6n squared minus n minus 2 subtract 6n squared minus 13n plus 2. And it's important to know that we're subtracting all of this. So let's move it over. You probably can't do this if you're writing this down. And we're going to take away all of this. So let's put it in a bracket. That's very important that we're taking away all of it. So we've got 6n squared, take away 6n squared, that's 0. We've got minus n minus minus 13n. So we've got minus n minus minus means add 13n. So if you had minus n and you're adding 13n, that'll be 12n. So we've got 12n there. Just to recap that, we had minus n minus minus 13n. So we're going to do minus n add 13n, which is 12n. And then finally, we've got minus 2 minus 2. minus positive 2. So we've got minus 2, take away 2. And minus 2, take away 2 would be minus 4. So the answer is 12n minus 4. And that's quite cool because we've got this quite complicated algebra and it just simplifies down to 12n minus 4. And we've been asked to prove that this is even. So we want to show this is even. So let's take 2 out as a factor. So 2 bracket, and then we've got 6n minus 2. And that because that's 2 times something, that's even. So therefore, it is even. Now this question here at this point is because we had 12n minus 4, we could have taken 4 out as a factor, so we could have written 4 bracket 3n minus 1, and that's 4 times something, and again that would be even also. I've just taken 2 out, you could do either one. Okay, let's have a look at our next question, question number 6. So question number 6, we've been asked to show that the sum of 3 consecutive even numbers is always a multiple of 6. So we want to find 3 consecutive even numbers. So 3 consecutive even numbers, well, let's choose 2n, that's an even number. 2n plus 2, that's the next even number, not 2n plus 1, that's odd. And then we've got 2n plus 4. They would be 3 consecutive even numbers. And we want to prove that their sum, what we get when we add them together, is a multiple of 6. So let's add them together and see what we get. So let's add them together. 2n plus 2n plus 2n, that's 6n. And then we've got 2 plus 4, that's plus 6. So we've got 6n plus 6. And we want to show that's always a multiple of 6. That's quite nice. If we take 6 out as a factor, we get 6 bracket n plus 1. And because it's 6 times something, it's a multiple of 6. So let's write that down. Therefore, a multiple of 6. And that's it. Okay, question number 7 says, prove the sum of 4 consecutive odd numbers is always a multiple of 8. So we want to find the sum of 4 consecutive odd numbers. So let's choose our odd numbers. So 2n is even, so 2n plus 1 is odd. The next odd number would be 2n plus 3 because 2n plus 2 is even. Then it'd be 2n plus 5 and 2n plus 7. I want to show that their sum, what we get when we add them together, is always a multiple of 8. So let's add them together and see what we get. So 2n plus 2n plus 2n plus 2n is equal to 8n. And then we've got 1 plus 3, that's 4. Plus 5, that's 9, plus 7, that's 16. So we've got that's equal to 8n plus 16. Now we want to show that's a multiple of 8, so if we take 8 out as a factor, we get 8 bracket, and then if we take 8 out, we would get n plus 2. And now we've got 8 times something, so that's going to be a multiple of 8. So let's write that down. Okay, let's have a look at our next question, question number 8. So question number 8 says, prove that 2n plus 9, close bracket squared, subtract 2n plus 5, close bracket squared, is always a multiple of 4. So we want to square this, and we want to take away our result and show it's a multiple of 4. So let's do that. So we've got 2n plus 9 multiplied by 2n plus 9. And then we've got our 2n plus 5 multiplied by 2n plus 5. So let's expand these and see what we get. So we've got 2n times 2n, that's 4n squared. We've got 2n times 9, that's going to be plus 18n. We've got 9 times 2n, that's plus 18n. And then we've got 9 times 9, that's going to be plus 81. And then whenever we simplify this, we've got our 18n plus 18n, that's 36n. So we've got 4n squared plus 36n plus 81. Now if we expand our second pair of brackets, we've got 2n times 2n, that's 4n squared. 2n times 5, that's going to be plus 10n. 5 times 2n, that's plus 10n. And 5 times 5 is 25. Now if we simplify this, that would give us 4n squared plus 20n plus 25. Now the question, we've been asked to take away our result, so we're going to take this away from this and we're going to show it's a multiple of 4. So let's just move it over a little bit. Okay, so we've just moved it over a little bit and let's take away all of this. And we're taking away all of this. And it's very important we put it in a bracket because we're taking away everything. If we were just to put a take away and then write our 4n squared plus 20n plus 25, we'd only be taking away the 4n squared and adding 20n and adding 25, but we need to show that we're taking away all of it. So we've got 4n squared, take away 4n squared, that's 0. Then we've got 36n, take away 20n. Well, 36n, take away 20n, that's going to be 16n. And then we've got 81 take away 25. And 81 take away 25 is equal to 56. So that would be 16n plus 56. Now we want to show this as a multiple of 4, so let's take 4 out as a factor. So 4 bracket. And then if we divide both of these by 4, 16n divided by 4 would be 4n. And then 56 divided by 4 is equal to 14. So that would be 4 bracket 4n plus 14. And because it's 4 times something, that's a multiple of 4. So let's write that down. And that's it. Okay, let's have a look at question number 9. Okay, let's have a look at question number 9. So question number 9 says, prove n plus 1 squared plus n plus 3 squared, take away n plus 5 squared, is equivalent to n plus 3 multiplied by n minus 5. Now in this question we want to either start with the left hand side of the identity or the right hand side of the identity, and this is an identity because we've got this equivalent to. Now I'm going to want to start with the left hand side because there's more I can do with this left hand side. I can expand these and so on, and hopefully I'll get to something which will factorize to this. So let's start with the left hand side. So we've got n plus 1 multiplied by n plus 1 plus n plus 3 multiplied by n plus 3, and then take away n plus 5 multiplied by n plus 5. So let's see what we get. So n times n is n squared, n times 1 will be plus n, 1 times n is plus n, and 1 times 1 will be plus 1. And then that would simplify to n squared plus 2n plus 1. Okay, next, and we've got plus, so then we've got n plus 3 times n plus 3, so n times n is n squared, n times 3 is plus 3n, 3 times n is plus 3n, and 3 times 3 is plus 9. And that would simplify to plus n squared plus, and 3n plus 3n is 6n plus 9. So we've squared our first two brackets. Now let's look at our next one. Now it's got to subtract here, so we need to be careful. So I'm going to put this in brackets, subtract, and then put in brackets. N times n is n squared. N times 5 would be plus 5n. 5 times n will be plus 5n, and then we've got 5 times 5 is plus 25. And I've put it in brackets because we're taking away all of this. Now we need to simplify, so we're going to do take away. Let's put it in brackets, n squared. 5n plus 5n will be plus 10n, and then we've got our plus 25. So we've squared our three brackets, and we've got our answers, n squared plus 2n plus 1. Then we've got plus n squared plus 6n plus 9. And then we've got our takeaway, and I've put this in brackets, n squared plus 10n plus 25. Okay, now let's simplify. Now I'm going to do the additions here first. So I'm going to do n squared plus n squared, that's 2n squared. 2n plus 6n, that's plus 8n. And 1 plus 9 will be plus 10. And then we're going to take away all of this, so take away n squared plus 10n plus 25. Now let's do our subtraction. So we've got 2n squared, take away n squared, that's going to be n squared. Now we've got 8n take away 10n, and 8n take away 10n will be minus 2n. And finally 10 take away 25 will be minus 15. So what we found, whenever we look at this left hand side, whenever we square all these brackets and then simplify it, we get n squared minus 2n minus 15. Now we want to show that's equal to n plus 3 brackets n minus 5. So if we were to factorize this quadratic, if we were to get this, then we would be done. We would have shown that this, all this, is equal to that. So let's see if we can factorize. So we've got n squared minus 2n minus 15. So let's put our brackets down, bracket, 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 bracket. Let's put an n at the beginning of both brackets. So we're looking for two integers that will multiply together to give us negative 15 and add together to be negative 2. Well, two numbers that will times together to be negative 15 and add together to be negative 2 will be, because 3 times negative 5 is negative 15, and 3 plus negative 5 would be negative 2. And if we have a look, that is the right hand side of this identity. So we have started with the left hand side, we've expanded and simplified and factorized, and we've got that's equal to the right hand side. So that's it, we've done. Okay, let's have a look at our next question, question number 10. Okay, let's have a look at question number 10. So question number 10 says, prove the product of two even numbers is always even. So in this question, we've been asked to show the product, that's what we get when we multiply, of two even numbers is always even. Now in this question it doesn't say consecutive even numbers, it just says even numbers, so they could be any even numbers at all. So let's choose an even number, let's call it 2n, and let's choose another even number, let's call it 2m, and let's find the product of those. So product is what we get when we multiply. So 2n times 2m would be equal to 2 times 2 is equal to 4, and then n times m, put them in alphabetical order, would be mn. So 2n times 2m will be equal to 4mm. Now to show this is even, we want to show it's 2 times something, so let's take 2 out and then brackets, and then dividing this by 2 would give us 2mn. So 4mm is 2 times 2mm, because it's 2 times something, therefore it's even. And let's just write that down, so therefore, and that's it, so we've written the product is even. Okay, let's have a look at our next question, question number 11. Okay, let's have a look at question number 11. So question number 11 says, prove the product of 3 consecutive odd numbers is odd. So we want to show the product, so what we get when we multiply, of 3 consecutive odd numbers, so 3 odd numbers that are consecutive, and we want to show that the answer, the result, is odd. So let's get our 3 consecutive odd numbers. So let's choose 2n plus 1, 2n plus 3, and 2n plus 5. So obviously 2n plus 2 would be even and 2n plus 4 would be even. So they are our 3 consecutive odd numbers. And we want to find their product, so we want to multiply them and see what we get. So let's start off by expanding our first pair of brackets. So let's multiply 2n plus 1 and 2n plus 3. And let's get that and then get our result and multiply it by 2n plus 5. If you need to recap on how to expand three brackets, go to Corbettmaths.com. I think it's video around about 15. It could be 16. It's around about sort of 13, 14, 15, something like that. There's a video on expanding three sets of brackets. So let's expand our first pair of brackets and see what we get. So 2n times 2n, that's going to be 4n squared. 2n times 3, that's going to be plus 6n. 1 times 2n, that's plus 2n, and 1 times 3, that's plus 3. And when we simplify that, we get 4n squared plus 6n plus 2n is 8n plus 3. So we've expanded our first pair of brackets. Now we still need to multiply that by 2n plus 5. So let's put that in brackets and let's put our 2n plus 5 beside it. And now we need to expand again. So that means we're going to multiply our 2n plus 5 by our 4n squared, by our 8n, and by our 3, and then we're going to simplify it. And then hopefully it's going to be odd. So 4n squared times 2n, that's going to be 8n cubed. 4n squared times 5 would be plus 20n squared. Now let's move on to our 8n. So 8n times 2n would be plus 16n squared. 8n times 5 would be plus 40n. And finally, 3 times 2n would be plus 6n, and 3 times 5 would be plus 15. Now let's simplify this. So that would be, well, let's look at our cube terms. We've got 8n cubed. Now our squared terms, we've got 20n squared plus 16n squared. That's going to be plus 36n squared. We've got 40n plus 6n. That's going to be plus 46n. And then we've got our plus 15. Now in this question, we're asked to show that that is odd. And if you look at it, well, we've got 8 times something plus 36 times something plus 46 times something. Well, it's all going to be even. And then we've got our plus 15. So we've got an even plus an even plus an even plus an odd. Well, an even plus an even plus an even plus an odd is equal to an odd. And you can just explain that. Alternative, another way to show that is if we factorize the first three terms and take 2 out, we would get, if we take 2 out of all of this, we would have 4n cubed plus, and dividing this by 2, 18n squared plus, dividing this by 2, 23n. So factorising the first three terms, we've got 2 times something, and then we've still got our plus 15. Now 2 times something is even, so we've got an even, and we're adding an odd, and an even plus an odd is equal to an odd. And that's it. So we're asked to prove the product of 3 consecutive odd numbers is odd. But if we take our 3 consecutive odd numbers, we expand and simplify, we get eventually an even plus an even plus an even plus an odd, which is an odd, or we can say the whole beginning is even plus an odd is equal to an odd. And that's it. Okay, let's have a look at our next question, question number 12. So question number 12 says, prove algebraically the sum of the squares of 2 odd integers is always even. So we want to prove that the sum of the squares, so we're going to square something, of 2 odd integers. Now, they're not consecutive odd integers, just 2 odd integers. So one odd integer could be 2n plus 1, that's an odd integer. And then another odd integer could be 2k plus 1. They would be 2 odd integers. And we want to show that the sum of the squares, so we're squaring them, and the sum, we're going to add our results. We're going to show that that result is always even. So let's expand our brackets and see what we get. So we've got 2n plus 1 multiplied by 2n plus 1. And then we're going to add 2k plus 1 multiplied by 2k plus 1. So 2n times 2n is 4n squared. 2n times 1 is plus 2n. 1 times 2n is plus 2n. And 1 times 1 is equal to 1. So when we simplify that, we get 4n squared plus 4n plus 1. Now next pair of brackets, we've got 2k plus 1 multiplied by 2k plus 1. Well, 2k times 2k is 4k squared. Then we've got 2k times 1, that's going to be plus 2k. 1 times 2k, that's plus 2k. And 1 times 1 is plus 1. And when we simplify this, we get, well, that's plus 4k squared plus 2k plus 2k, that's 4k plus 1. So we've got 4n squared plus 4n plus 1 plus 4k squared plus 4k plus 1. Now we want to show this is even, so let's simplify it. So simplifying out, collecting our like terms. Well, our like terms are neither numbers, so it's going to be 4n squared plus 4n plus 4k squared plus 4k. And then we've got 1 plus 1, that's equal to 2. And now let's factorize this by taking 2 out because we want to show it's even. So if we take 2 out, we get 2n squared plus 2n plus 2k squared plus 2k plus 1. So that's 2 times something, so therefore it is even. Okay, let's have a look at our next question. So question number 13 says, prove that when 2 consecutive integers are squared, the difference is equal to the sum of the two consecutive integers. So in other words, we want to show that whenever two consecutive integers, so that's going to be numbers such as n and n plus 1, we haven't been told if they're odd or even, so we can just choose n and n plus 1. So we want to prove that whenever they're squared, so whenever we square them, that the difference is equal to the sum of the two numbers. So let's first of all find what we get whenever we square them. So n times n is equal to n squared, and n plus 1 times n plus 1, well, expand on that would give us n times n is n squared, n times 1 will be plus n, 1 times n is plus n, and 1 times 1 is plus 1. And when we simplify that, we get n squared plus 2n plus 1. So we've squared our two consecutive integers, and the question says that the difference, so let's find the difference, so our n squared plus 2n plus 1, take away our n squared, and whenever we take them away, we get n squared take away n squared is 0, so we're left with 2n plus 1. So that's the difference. The difference of the squares of the two consecutive integers is equal to the sum of the two consecutive integers. So let's add the two consecutive integers that we started with. So we'd have n plus 1, and n plus n plus 1 is equal to 2n plus 1. So that means that the sum of the two consecutive integers is 2n plus 1. The difference of the squares of the two consecutive integers is 2n plus 1, and they're equal to each other. So that's it. And I've written, therefore, they're equal. Okay, let's have a look at question number 14. So question number 14 says, given x is a positive integer, prove that 2x plus 3, close brackets squared, minus 3x brackets x plus 2, close brackets, is a square number. So let's expand this and see what we get. So let's square our first bracket. So we've got 2x plus 3 multiplied by 2x plus 3. 2x times 2x is 4x squared. 2x times 3 would be plus 6x. 3 times 2x is plus 6x, and 3 times 3 is plus 9. And whenever we simplify this, we get 4x squared. 6x plus 6x is plus 12x, and then we've got our plus 9. So that's what we get whenever we expand our first bracket, so whenever we square our first bracket. And then, so we've got 4x squared plus 12x plus 9. Now we're going to take away 3x bracket x plus 2. So let's expand this and see what we get. So we've got our 4x squared plus 12x plus 9. Now we're going to do minus 3x times x. Well, minus 3x times x would be minus 3x squared. And then we've got minus 3x times 2. Well, minus 3x times 2, well, a negative times a positive is a negative, and 3x times 2 is 6x. So that gives us 4x squared plus 12x plus 9, take away 3x squared, take away 6x. And we want to show this as a square number, so let's simplify this. 4x squared take away 3x squared, that's going to be x squared. We've got our 12x take away 6x, so that's going to be plus 6x. And then we've got our plus 9. Now we want to show this as a square number, so what we're going to do now is we're going to factorize this and see what we get. So if we factorize this, we've got a quadratic, so let's factorize it, so x, and two numbers that times together to be 9 and add together to be 6, that's going to be plus 3 and plus 3. And as you can see, that would be equal to x plus 3 squared. And that's it, that is a square number, so therefore it is a square number. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 15. So question number 15 says, prove the sum of the squares of 3 consecutive positive integers is always 1 less than a multiple of 3. So let's choose our 3 consecutive positive integers. So it's going to be n plus 1, and n plus 2. And we want to show that the sum of the squares, so we're going to need to square these. So n squared is just n squared. Then we've got n plus 1 squared, so that's going to be equal to n plus 1 multiplied by n plus 1, and whenever we do that we get n times n is n squared, n times 1 is n, and 1 times n is n, so it's going to be plus 2n, and then we've got our 1 times 1 is plus 1. And finally we've got our n plus 2 squared, so it's going to be n plus 2 multiplied by itself, n plus 2, and whenever we do that we get n times n is n squared, n times 2 is plus 2n, and 2 times n is 2n, so when we add them together we get 4n, and finally 2 times 2 is plus 4. So we have got our 3 consecutive positive integers, n plus 1, and n plus 2. We've been asked to show the sum of the squares of them, so the squares of them would be n squared plus 2n plus 1, and n squared plus 4n plus 4, and we'll find the sum of those. We're going to need to add that together, so let's add those together. N squared plus 2n plus 1 plus n squared plus 4n plus 4. And when we add those together, we get n squared plus n squared plus n squared is 3n squared. 2n plus 4n is plus 6n, and 1 plus 4 is plus 5. And we want to show that the sum of the squares of those three positive integers is always 1 less than a multiple of 3. Now if you ever look at what we've got, if we were to add one more onto it, so if we would have one more, that would be 3n squared plus 6n plus 6, that's one more. And that is a multiple of 3 because we can factorize it and take 3 out, and that would give us n squared plus 2n plus 2. So that is a multiple of 3. And what we've got is 1 less than that because it's not plus 6, it's plus 5. So what we've got is 1 less than a multiple of 3. So let's write that down. So just written down, therefore, 3n squared plus 6n plus 5 is 1 less than a multiple of 3. Okay, let's have a look at our next question, question number 16. Okay, question number 16 says, prove algebraically that 4n plus 1 squared minus 2n minus 1 is an even number for all positive integer values of n. So let's just square our bracket and see what we get. So we've got 4n plus 1 multiplied by itself, so 4n plus 1. And so 4n times 4n is 16n squared. 4n times 1 is plus 4n. 1 times 4n is plus 4n. And 1 times 1 is plus 1. And when we simplify that, we get 16n squared plus 8n plus 1. Now we've got that, so we've got our 16n squared plus 8n plus 1, and we're taking away in brackets 2n minus 1, close brackets. So we now want to show this is an even number, so we can at this point take away 2n from this and take away minus 1 from this. Or another thing we can do is we can actually expand our bracket, and here there is actually a minus 1 here because it's minus this bracket, so the same as minus 1 of this bracket. So if we had a minus 1 here, we could multiply out what's in the bracket by minus 1. So that would give us 16n squared plus 8n plus 1. And then we've got minus 1 times 2n, that's going to be minus 2n. And we've got minus 1 times minus 1, that's going to be plus 1. And if you think about it, we were taking away 2n, so it's going to be minus 2n, and we were taking away minus 1. Well, if you minus and minus 1, that's the same as adding 1. Okay, now let's simplify this. So we've got our 16n squared. We've got our 16n squared. We've got our 8n take away 2n. That's going to be plus 6n. And then we've got our 1 plus 1, which is plus 2. And we want to show that this is even. So we factorize this. We would get 2 bracket 8n squared plus 3n plus 1. So it's 2 times something. So therefore, it is even. Okay, let's have a look at our next question. Okay, let's have a look at question number 17. So we've been asked to prove that 3n brackets 3n plus 4 close brackets plus n minus 6 squared is positive for all values of n. So let's expand and simplify this and see what we get. So 3n times 3n would be 9n squared, and 3n times 4 would be plus 12n. Then we've got plus, and then we've got this bracket squared, so it's going to be n minus 6 multiplied by n minus 6. So that's going to be 9n squared plus 12n. And then we've got plus, we've got n times n, that's going to be n squared. N times minus 6 is going to be minus 6n. Minus 6 times n, that's going to be minus 6n. And minus 6 times minus 6, well, negative times a negative is a positive, so plus 36. And then simplifying this would give us, well, we've got our 9n squared plus 12n. And then we've got plus n squared. And then we've got minus 6n, that's going to be minus 12n plus 36. And let's simplify again. So we've got our 9n squared plus n squared. That's going to be 10n squared. We've got 12n, take away 12n, that's 0. And then we've got our plus 36. So whenever we expand and simplify, we get 10n squared plus 36. And we've been asked to show that this is positive for all values of n. So if we consider n, we're going to square it. So that means that if we had n squared will always be bigger than or equal to 0. Because if we had 0, 0 squared is 0. If we had 5, 5 squared is 25, or if you had minus 5, well, negative 5 times negative 5 is 25. So the smallest possible value for n squared would be 0. Whenever you square something, the smallest possible result you could get is 0, and then it could be anything bigger than 0. So we've got n squared is bigger than or equal to 0. And if you consider the quadratic graph looks something like this, where it goes down, it goes through the origin and comes up again like this, okay? So whenever we have n squared, the smallest value we can ever get is 0. So n squared is bigger than or equal to 0. Now if we multiply that by 10, well, the smallest value could have been with 0. If we times that by 10, that would still be 0 because 10 times 0 is 0. So 10n squared would be bigger than or equal to 0 as well, because the smallest value could have been at 0. If you times that by 10, you still get 0, and all those positive values, if you times them by 10, they just get 10 times bigger. Then we're going to add 36. So we had something that is bigger than or equal to 0. If you add 36 to it, that means that it can no longer be equal to 0. That means it must be positive. So that means that 10n squared plus 36 must be positive. It must be bigger than 0. So therefore, it is always positive. Therefore, 10n squared plus 36 is always positive. And that's it. Okay, let's have a look at our next question. Okay, question number 18 says the first 5 terms of a linear sequence are 5, 11, 17, 23, and 29. Find the nth term of the sequence. So let's see what the sequence is getting bigger by. It's getting bigger by 6, 6, 6, and so on. So we've got our 6 times table, so 6n, and we've got 6, 12, 18, 24, 30, and so on. Now our sequence is one smaller than that, so our nth term for our sequence will be 6n minus 1. Then the question says the sequence is generated, a new sequence is generated by squaring each term of the linear sequence. So we're going to square this. So that means we're going to do our 6n minus 1 squared. And then we're going to add 5. Okay, so we're going to be squaring every term in that sequence. So every term in this sequence, we're going to square it. So that means we're going to be squaring our nth term. And then we're going to be adding 5. So let's do that. So we've got our 6n minus 1 squared plus 5. So let's expand this and see what we get, and then hopefully prove that all of those numbers are divisible by 6. So expand on this bracket, well, it's going to be 6n minus 1 bracket 6n minus 1, and then we've still got our plus 5. 6n times 6n is 36n squared. 6n times minus 1 will be minus 6n. Minus 1 times 6n is minus 6n. And minus 1 times minus 1, well, negative times a negative is a positive, so plus 1. And then we've still got our plus 5. And then collecting our like terms here, simplifying this will give us 36n squared. Minus 6n minus 6n would be minus 12n, and 1 plus 5 is equal to plus 6. So that means our new sequence has an nth term of 36n squared minus 12n plus 6. I want to show that all those terms are divisible by 6. If we can factorize this and take 6 out, then all the terms are divisible by 6. So let's try that. So 6 bracket, and we would have 6n squared minus 2n plus 1. And therefore, all terms. And that's it. So I've just said that all terms are multiples of 6 because we've got 6 times something, and so they're divisible by 6. Okay, let's have a look at our next question. So question number 19 says, prove the product of 2 consecutive even numbers is a multiple of 4. So we want to find the product, so again, when we multiply, 2 consecutive even numbers. Okay, so let's choose an even number, 2n. The next consecutive number will be 2n plus 1. That's odd, but we want consecutive even numbers, so we're going to choose 2n plus 2. And we want to show the product, so we're going to multiply them together, and we're hopefully going to get that to multiple of 4. So we're going to multiply this by 2n. So 2n times 2n is 4n squared, and 2n times 2 is plus 4n. So that means that whenever we multiply 2 consecutive even numbers, we would get 4n squared plus 4n. And let's take 4 out as a factor, so 4 bracket n squared plus n. And that's 4 times something, so therefore a multiple of 4. Okay, let's have a look at our next question. Question number 20. So question number 20 says, prove when any odd integer is squared, so let's get an odd integer, 2n plus 1, and squared, so it's going to be squared. The result is always one more than a multiple of 8. So let's square this and see what we get. So that's going to be equal to 2n plus 1 multiplied by 2n plus 1. 2n times 2n would be 4n squared. 2n times 1 will be plus 2n, 1 times 2n will be plus 2n, and 1 times 1 is plus 1. And then whenever we simplify this, we'd get 4n squared. 2n plus 2n is plus 4n plus 1. Now we want to show that that's always one more than a multiple of 8. Now we want to show that this is always one more than a multiple of 8. Well, because it's one more, because we've got this plus 1, that's great, that would be one more than. And so if we show that 4n squared plus 4n is a multiple of 8, then 4n squared plus 4n plus 1 will be one more than a multiple of 8. So we really need to show that 4n squared plus 4n is a multiple of 8. So let's focus on this 4n squared plus 4n. So let's go over here. 4n squared plus 4n. Let's see if we can show this as a multiple of 8. So let's factorize this and see what we get. So we've got 4n squared plus 4n. Well, we can take a 4 out and an n out, so 4n bracket. And then 4n squared divided by 4n, that will just leave us with n. And 4n divided by 4n, that's going to be 1, so plus 1. So we've got 4n bracket n plus 1, and we want to show this as a multiple of 8. Now if we have a look at this, we've got n times n plus 1. So we've got n plus 1. So if n is a number, n plus 1 is the next number. So if n is even, this would be odd, or if n was odd, this would be even. So one of these two numbers is even. So we've got an even number times 4 times an odd number. Then even times 4 would be a multiple of 8, because if you have an even number times 4, it must be in the 8 times tables. So that means that this must be, it's an even times an odd times 4. Well, 4 times the even would be in the 8 times tables, and if you times that by an odd number, that would still be in the 8 times tables. That means that this must be a multiple of 8. So let's write that down. So I've just written down either n or n plus 1 is even, so either of those is even. So that means that n times n plus 1 and even times an odd is an even. So 4 times an even is a multiple of 8. So if we go back to what we had here, we had 4n squared plus 4n plus 1. So whenever we looked at the first two terms, we knew that whenever we factorize them is equal to 4n bracket n plus 1. And then we've still got our plus 1. Now this was a multiple of 8, we're adding 1, so therefore, so I've just written 4n bracket n plus 1, close brackets, plus 1 is 1 more than a multiple of 8. And that's it. Okay, let's have a look at our next question. So question number 21. So question number 21, we've been asked to prove that the product, what we get when we multiply something, of two odd numbers is always odd. So we want to find two odd numbers. So remember that 2n would be even, so 2n plus 1 would be odd. And then another odd number, now they're not consecutive, well let's choose another odd number, let's choose 2k plus 1. So there's two odd numbers because 2n is even plus 1 is odd, 2k is even plus 1 is odd. I want to show that they're products, so let's multiply them together. And we want to show that that's always odd. So let's expand these brackets and see what we get. So 2n times 2k, that's going to be 4kn. 2n times 1, that's going to be plus 2n. 1 times 2k, that's going to be plus 2k, and 1 times 1 is equal to 1. So we've got 4kn plus 2n plus 2k plus 1. And we want to show that this is odd, so if we look at the first three terms, we've got 4 times something, 2 times something, and 2 times something. That's even, even, and even. So let's write that down. Let's do 2 bracket and factorize the first three terms. That would give us, if we take 2 out of here, we're going to be left with 2kn. If we take our 2 out, we're going to be left with plus n. And if we take our 2 out, we're going to be left with plus k. Close brackets. And then we've still got our plus 1. So that means that we've got an even. So we've got an even. And then we're adding 1, so adding an odd. And that would obviously be equal to an odd. And that's it. So we've shown what we needed to show. Okay, let's look at our next question. Question number 22. Okay, let's have a look at our next question. So question number 22 says, prove algebraically every term in the sequence of n squared minus 12n plus 36 is positive. Now I really like this question because I like the topic completing the square. And this question, if you use completing the square, makes it really quite straightforward and easy. So if you need a recap on completing the square, go to Corbettmaths.com and watch the video on completing the square. And let's then, after you've watched that video, let's presume that you know how to complete the square, and let's have a look and see how you do this question. So we've been asked to show that every term in this sequence is positive. So we've got n squared minus 12n plus 38. So let's write that down. N squared minus 12n plus 38. And we want to show every term is positive, so we're going to complete the square for this and see what we get. So if we complete the square, well, let's remember, open up our brackets, put our n. We're going to half the coefficient of our n term, or our x term, the term in the middle here. So half of minus 12 is minus 6, close brackets, squared. Then you take away whatever you get squared, so minus 6 times minus 6 is 36. So we're going to take away 36, and then we're going to put on our 38 on the end, or plus 38, so plus 38. Remember to watch that video on completing the square if you need a recap on that. So to complete the square for this, you half the minus 12, which is minus 6, you put it in the bracket, you put your squared, you take away whatever that is squared, so minus 6 times minus 6 is 36, so we write our minus 36, and then we put our plus 38 on the end. So let's simplify this and see what we get. So the bracket, we'll leave that as it is, n minus 6, close bracket, squared. We've then got minus 36 plus 38. Well, minus 36 plus 38 would be 2, so we've got plus 2. Now this is great because this now means that we've got enough information to show that every term in this sequence is positive. Because, now let's have a look at this, because we've got our n minus 6 and then we're going to square it. So that means we're squaring something. Now, whenever we square something, the smallest possible result you can get 0, because 0 squared is 0. If you square positive, that's positive. If you square negative, that's positive. But 0 squared is 0. So that means that if we have our n minus 6 close bracket squared, I know that's always going to be bigger than or equal to 0, because the smallest value can be 0. So we had our n minus 6 close bracket squared, which is 0 or positive, and then we're going to add 2. Now, whenever we add 2 to that, it no longer can be equal to 0, because if this was 0 and you're adding 2, you're not going to have a positive number. So that means that n minus 6 close bracket squared plus 2 is going to be bigger than 0. So that means all the terms in the sequence are going to be bigger than 0. All the terms in the sequence are going to be positive, and that's it. Okay, let's have a look at question number 23. And question number 23, our last question, says, prove the sum of the cubes of 2 consecutive odd numbers is always a multiple of 4. So 2 consecutive odd numbers, so that's going to be 2n is even plus 1. That's going to be an odd number. And our next odd number will be 2n plus 3. So they are 2 consecutive odd numbers. You could have chosen 2n minus 1 and 2n plus 1. I like to choose 2n plus 1 and 2n plus 3. I want to prove that the sum of the cubes, so we're going to cube these, so we're going to need to work out what 2n plus 1 bracket 2n plus 1 bracket 2n plus 1 is whenever we expand those, and we're going to need to do the same for our 2n plus 3 bracket 2n plus 3 bracket 2n plus 3. So we're going to need to cube both of these, and we're going to add our results together and hopefully show that that's a multiple of 4. So let's do that. So let's start off with our 2n plus 1 cubed. So that's 2n plus 1 times 2n plus 1 times 2n plus 1. So expand on our first pair of brackets. That would give us 2n times 2n. It's going to be 4n squared. 2n times 1 and 1 times 2n. That's going to be 2n and 2n. Add them together will be 4n. And then we've got our 1 times 1 is going to be plus 1. So whenever you multiply these first pair of brackets, you would get 4n squared plus 4n plus 1. And we're going to need to multiply that by 2n plus 1, so 2n plus 1. And then multiplying this, we're going to multiply the 2n plus 1 by 4n squared, by 4n, and by 1. So 4n squared times 2n will be equal to 8n cubed. 4n squared times 1 will be equal to 4n squared. Now let's move on to our 4n. 4n times 2n would be equal to 8n squared. And 4n times 1 would be plus 4n. And then we've got our 1 times 2n, that's going to be plus 2n. And our 1 times 1 is going to be plus 1. So now we just need to simplify this. That would give us 8n cubed plus 12n squared plus 6n plus 1. Fantastic. Now let's do the same for our 2n plus 3 cubed. So we've got our 2n plus 3 times 2n plus 3, our first pair of brackets. And we multiply these two pair of brackets we would get. That's equal to 2n times 2n is 4n squared. Then we've got 2n times 3 and 3 times 2n. Well, 2n times 3 is 6n, and then we get another 6n, add them together will be plus 12n, and then we've got 3 times 3, which is plus 9. So that's what we get when we expand the first pair of brackets, and we still need to multiply that by 2n plus 3. So let's multiply both of these, the 2n and the 3, by our 4n squared, our 12n, and our 9, and see what we get. So 4n squared times 2n, that's going to be 8n cubed. 4n squared times 3, that's going to be plus 12n squared. 12n times 2n will be equal to 24n squared, and 12n times 3 will be equal to plus 36n, and 9 times 2n will be plus 18n, and 9 times 3 will be plus 27. And when we simplify this, we get 8n cubed plus 36n squared plus 54n plus 27. Finally, we just need to add those to get the sum. So let's add those together and see what we get. So that's going to be, if we add them, 8n cubed plus 8n cubed, that's going to be 16n cubed. 12n squared plus 36n squared, that's going to be plus 48n squared. 6n plus 54n will be equal to 60n. And 1 plus 27 will be equal to 28. Now we want to show in the question, we've been asked to show that's a multiple of 4, a multiple of 4. So if we go back down, if we can factorize this and take 4 out, then it's 4 times something, so therefore it's a multiple of 4, and we're done. So let's take 4 out, so 4 bracket, and divide all of this by 4, that would be 4n cubed plus 12n squared plus 15n plus 7. And that's 4 times something, so therefore it is a multiple of 4. And that's it. So these have been the video solutions to the Algebraic Proof practice questions on Corbettmaths. If you need any extra help on that, feel free to watch the Corbettmaths video on Algebraic Proof. Also, some other useful videos for this video where you're completing the square and expanding three brackets, also factorizing, so make sure you're confident with those as well. I really hope you find this video useful. If you have found it useful, could you please like it, please subscribe to the YouTube channel, and all the very best with your studies. Cheers, bye bye.